Hello, welcome. Can you guys hear me? It's okay? Okay. My name is Danny Schneider. I'm a program manager in the AI platform team, and there I'm working on Azure ML as an offering. So are there any data scientists in the audience or people that would kind of, oh, they're awesome. Yeah, okay. So there's some. So Azure ML is a tool to help the data scientists be more productive using the Azure cloud, basically. So I have a quick talk today, and the product that I'm working on is actually the Azure ML Python SDK, which gives you the ability to do pretty much everything that you can do with Azure ML through Python, right? I have a very quick agenda, only 20 minutes. I want to spend pretty much 15 minutes, if not more, demoing what we can do with the Python SDK. Just as a precursor, it's something that you will see come out later this year. But if you're interested in participating in our private preview, please see us over there at the booth. There's an Azure machine learning booth right in the area in the AI data and area right across from Theater 2. Please go there and have your badge scanned, and then we can see whether we can kind of take you into the public preview. So here's the agenda. I'm going to just give you a real quick overview of what Azure Machine Learning is and where it sits in our offering of the AI developer offering by Microsoft. And then we will give you a brief overview of the Python SDK, but I'm actually really going to show it through the demo rather than through many slides. Right? So here we have the overview of the Microsoft AI developer platform. And there's like three big pillars on the top left here, which is conversational AI, which is basically building bots to have intelligent conversations with your customers through websites or through Cortana, through Skype, different ways. There was some even in the keynotes, and they're planning nice sessions, interesting sessions about there and how do you create those. There is another pillar, which is the cognitive services. That's where you probably want to start if you're not very deep into data science yet, or if you actually have a problem that is so standardized that we've already solved it and put it into a web service, right? So here you're actually interacting more as a developer with the web service in order to solve your problem, be it indexing a video, transcribing the contents of text, of spoken words, spoken recordings, or just image classification. These are all problems. Translation. These are problems like this. A huge amount of cognitive services by now, and they're really, really useful. Now, when we come to the custom AI part, this is where Azure ML starts to play a role. And here you're actually the data scientist that wants to train and build a custom model. Right, so it's no longer, okay, I'm just going to take your model from somewhere and then I'm going to apply it. I'm actually building my own. I'm using TensorFlow, CNTK, Chainer, Caffe, PyTorch, one of those tools, or just plain scikit-learn, plain machine learning algorithms in order to solve my problem, right? Whatever that might be, right? So that's where Azure ML sits in this. Here's some like rundown of a few features that we have. So things that you can do, you can manage your training jobs locally. And so Azure ML, and I'm going to show that in the demo as well, is helping you to scale it up into the cloud. So you basically you download your TensorFlow file maybe from GitHub, and then you have fairly straightforward, easy ways of kind of bringing it and running it in the cloud. Because what often happens is you train your model and then you run out of memory. Or you train your model and it takes actually much longer than you thought, or than you have time for, or compute. So that's where Azure is really useful because we have a lot of compute and it's really easily accessible, right? So that's kind of the scaling up, and then out is like, hey, I don't want to just train on one GPU. I want to train on 10 or 100. Right? So in order to kind of scale up the training process, make it faster. Yeah, so as it says here, running distributed TensorFlow, CNTK training jobs is something that we help with. Then hyperparameter search, I'll show that as well. It's something that happens basically to every model. It needs to be, you always have hyperparameters that need to be tuned, right? So I have like things like a learning rate, for example. There's no good value for a learning rate. It depends on your model and it depends on your data. So that's something I'll show you as well. we capture the logs of all your runs, we catalog them, we capture the model that you create, any of the outputs that you create, so you can go back to them later. Like anything that you've created in terms of metrics for your jobs, we'll capture that, and then you can kind of pull it in and go back to it later, or you can iterate over it. You can draw pictures like graphs with it, and so really useful. You can do like a leaderboard. You see like which of the models that I ran, which one performed the best, what were the parameters that I was using, what was the code I was using. You can pull that back in, right? And of course, all of that, you can use your favorite IDE, you can use your favorite editor, you can use that in notebooks, and you can use the framework that you want to use, like TensorFlow, CNTK, SparkML, or any other framework that is Python-based. That's basically where we're at right now. Yeah, so this is the Azure ML SDK, just a high-level overview. It kind of mirrors the feature set, so all the things that I just talked about, you can do there. And let me just jump into the code to show you what I'm doing. Oh, actually, there's one more here. Like this is kind of a rundown of what I'm going to show you. We're going to train a DNN on a batch AI cluster. We're actually going to deploy. We're going to show you how to deploy a batch AI cluster first, and you can train on a batch AI cluster. When we're going to perform the hyperparameter search for that DNN, we're going to pull data from the run history, which is where we're logging all the runs that you make. And then we're going to download the best model, right? So it's like a typical flow. You run 100 runs, and then you download the best model, and then we're going to deploy an ACI compute, Azure Container Instances, and then put that model on that compute so I can score it through the web, right? So that's like I got 15 minutes, so let's see how far we get. So what I'm using is the MNIST data set. Who knows the MNIST data set? Who has heard about it? So it's hand-written characters. It was the Postal Service. They needed a way to kind of get to scan postcodes, to understand postcodes, handwritten postcodes, and so it's kind of the most basic example that people use to teach and showcase DNN training, because it really performs well with convolutional neural networks. So my computer went to sleep. Okay. So first of all, we're going to start with a workspace. And if anybody has already used Azure ML, they know that the workspace is that thing that has all kinds of things attached to it. And that is kind of the central place to go to provision compute, to deploy web services, attach compute targets, attach and get models, and so on. So that's what we've created now. And the second step is provisioning of a batch AI cluster. So this takes a little longer than we have time for, so I'm actually going to take one that I've provisioned earlier. But just to show you, the way it works is you have a provision config. Here what we're saying is we want VM size NC6, which is our GPU compute, the smallest GPU compute that we have. And this cluster is supposed to be between 0 and 4 nodes, which means it's going to be 0 nodes if there's no job running on it. And as soon as I schedule work on it, it's going to auto-scale. Right? It's going to scale up to all the way to 4 and not higher, because that's maybe how much quota I have, how much money I want to spend. I want to make sure I'm not, I want to be cautious with my cost. And once those jobs are completed, it'll scale down again. And so you're really only paying when you're running the job, right? So the way it works, like you create on the workspace, you say, okay, I want to create this compute target. I'm going to give it a name with this configuration here. And then I'll need to wait for the provisioning. And once that's completed, I can actually retrieve it from the workspace again, which is what I'm doing right now, and says, okay, it's still telling me, yeah, the provisioning succeeded, right? So the other option is you have already a batch AI cluster provisioned somewhere. Somebody like your IT department has it for you, and so you want to bring that one in, so you can do that too. You can just attach it, and then you have your compute attached to your workspace. So now we're actually coming to do some training here, right? So what I'm starting off with is this entry script here, which is a MNIST training for TensorFlow. So that is really pretty much downloaded from the website, and from the TensorFlow website as an example. And we made just one change here is we added the logging so that Azure ML actually knows what the result is of the runs that we're performing and how it's progressing over time, right? So this is how like a typical, this is like how a neural network is being built using TensorFlow, right? You got like convolutional layers and then ReLUs, the activation layers, and so on and so forth. So that's just stuff that data scientists do and how they build their models. And then there's this loop where you usually do the training run, right? And as part of the training run, we're actually logging the accuracy. So whichever run, we're tracking how good is the accuracy of the model so far, and then we'll log it over to Azure ML so that we can present it back to the user, right? So I'm going to kick off this job. And as this is basically just defining the job, just like I had the configuration definition of the batch AI cluster further up. This is just the definition of the job, and kicking it off is by means of this fit function on this estimator object, on this TensorFlow object. This is a pattern that we've taken from scikit-learn. They use that as well. It's very kind of known to people that do traditional machine learning with scikit-learn. The fit function is actually what fits the data to the model, or the model to the data. So that you end up with weights that represent best fit to the model, to the data. And so you can say, so what's the status? Okay, you can see that run is actually, the driver log is already starting to fill up. And I can just go and say, wait for completion, show output true, and that will show me the output of the run right here in the notebook, right? So it just keeps flowing in here as it's doing work. It's giving me whatever kinds of warnings that I have because I'm using not the very latest version of the certain constructs here, right? But you see it's kind of starting to give me accuracy readings back. So this is blocking my notebook now. It's kind of not cool. So I'm going to stop this. Instead, we have a widget that that allows you to monitor this in the background, and you also see all the metrics. And so it's kind of a prettier way to view this. Here you see the log, which is the same one you just saw. So this one's going to keep updating. And then here's all the data that's been logged. And as soon as something gets logged multiple times, so the accuracy and the iterations, for example, they get logged with every iteration of the training. We'll turn this into a graph. So hopefully there you go, right? So here's the graph, and it's starting to run. I'm thinking we're running this for like 10 iterations, which is actually kind of short for this model. It needs to run for more like 100, and then it gets really good accuracy on the problem, like 99% accuracy. But here, we'll just 10 is fine, right? So these metrics that I've been seeing here and here, I can just pull them out programmatically from the job. So I can go and just ask the run job, which is what I got back from that fit function, right? I just ask it, hey, give me the metrics, right? And as this thing progresses, I get more metrics out here as well, right? So I get 3 metrics here, and then the next time I'm going to get like, this is going to continue to fill up as the job reports more data. Okay, so this is all nice, so I can run a single job. Now I see this thing is actually learning something, it's working for me, but now I need to find out, for these parameters here that I was using the learning rate of 0.001, and I was using a keep probability of 0.5. I'm not really sure whether those are the best values or not, right? So there's really no way of knowing other than trying this out, right? So what you do is you run a hyperparameter tuning job, right? And I'm going to kick this one off because it takes a while to start, and I want you to know kind of some of the results before I talk about it. So the first thing you need to do is you need to define your parameter sampling space. So you're basically saying learning rate can be either of those values. I'm saying it's going to be a choice of between, it could be 0.0001 or 0.001, or, you get it, right? So these are the values, I'm just enumerating them, right? Another way of expressing my parameter space, or part of my parameter space, is by defining a distribution, right? So here, for example, for the key probability, I'm actually using a distribution. I'm saying use a uniform distribution across the space from 0.5 to 1.0, right? So that's where you want to sample from. And every time that hyperdrive is going to launch a new job for me, it'll go to that space and randomly sample a value pair of it, right? A value in that n-dimensional space, two-dimensional space in my case, right? And then we have something else, which is an early termination policy, which is, in essence, it kills jobs that don't look good. And as a data scientist, you look at jobs and you see, well, yeah, okay, that one I don't need to run any longer, and then you can go and kill it by hand. Well, the machine can do that too for you, right? Especially when you run 100 jobs and you run like 20 in parallel, it becomes a bit of an arduous task to do that by hand. And so what Hyperdrive does is it will automatically look for those poor jobs and kill them based on a certain criteria, which I'm describing here in this policy, right? And then all I need to tell it is basically, as I put the config together, I need to say, hey, what is the metric that I'm actually after? And it needs to be a metric that my job is reporting back. So I'm after the accuracy, which is like how many of the classified numbers that I take, I actually classify correctly. That's the accuracy of my model, right? And I want this actually to be maximized. I don't want it minimized, I want it maximized. I want maximum accuracy. And so it's going to kill jobs that aren't looking good by that criteria, right? And then I say I want 20 runs, usually one more, but for interest of time. And I want 5 to run concurrently, no more than 5. And yeah, and then I'm basically going to shoot that job off by saying, Hyperdrive, search me something, right? And again, here we have a widget, because there's many more jobs in play now. There's not just one job. And so we're going to show these next to each other. Okay, so I got a bunch of jobs that are they're reported as starting, but they actually already started. There's still some issues in some of the reporting here, but you can see there's some jobs here, and some of them are already. Looks like. Yeah, they're still reporting data. Hyperdrive hasn't really decided yet which one to kill, so it's only kind of looking at every so many steps as by your definition. So we'll come back to this one in a minute. Okay, and now the problem is, assuming now we have found we've run this all through, and it's you can see like okay, so it's kind of progressing, and I'm actually going to go to like an older run that I did earlier, since this one is still running, and then we can go and just download all the data from it and pull it just in a pandas data frame. I mean, you could do it any way you want, right? But that's just what I'm doing right now. So again, speed here is something that we'll definitely improve on by the time we ship this. But I'm just downloading like one job by one, and then I'm sorting it. Descending by accuracy, so the one with the highest accuracy is at the top. So I can see, okay, my best job here was 98% accuracy, and that was the probability that was used, and that was the learning rate that was used, right? And yeah, so actually, if you want to plot that, it's actually nicer if you have a few more. So yesterday I ran something with 100 jobs, and then you can plot these just using matplotlib. So this is just Python here, and here you can see like yellow is good, and you can see which area is giving you the best results. So it's somewhere actually quite in the middle here, where we're actually getting the best results. So you might want to go and based on this, maybe do another run that actually narrows down the search field, and then just keep looking more in the middle to really find that optimal spot, right? But it's really, I mean, it's like pulling it out and just plotting it is all just Python. This is not, and that's the beauty of the SDK. It really integrates well with what's already there. We're not making all of this. We don't reinvent anything that isn't already there. Okay, so yeah, the top run obviously is the first one in that list, right? So in this case, from the prior run, so that was what it reported. So now, since we're recording everything, we can see what this run has saved. So the outputs folder is a special folder for us, because by default we scrape it after your run, and we just copy it over to the artifact storage on blob storage and keep it for you. And here you see what we scraped out of the outputs folder, and that's basically that model. It's actually represented by 4 files, right? And then there's the logs that you can also get to and download. So what I'm doing now is I'm just downloading those files, and this is actually a 30 megabyte model, so it takes a little while. So I'm going to have to interrupt this and go to my previously saved model. And now I want to test this model locally. For that, it's just a TensorFlow model that needs as an input an image. The image we will represent as a JSON, as a base64 encoded binary that's put into a JSON, right? And that's what this function here is doing, right? And then I can basically take that model that I have locally and score it. And the scoring happens by means of the other script that I had pulled down, which is the score script. And it's this run function. It basically does the reverse. It takes in a JSON and it unpacks it back into an image, right? It takes a base64 encoded image and turns it back into an image, and then it sticks it into a TensorFlow graph and runs it. So this is, again, something that a data scientist would have in order to score their model, because they need to understand how to run it in the end, right? And so what we have here is like, okay, we have this model, and we're scoring it, and the number that we're scoring is actually, this image is actually a 9, so yes, that was correct. So now it's the last step. We're actually going to deploy this to an ACI storage, so ACI target. Here's the same pattern. We always define a configuration and then we deploy it. So we have the deploy configuration that actually contains how much memory I want and how many cores, right? And then there's this deploy function which deploys a web service, which basically rolls like the image creation based on a YAML file and a Python environment, together with turning that into a web service that gets then put onto the compute, right? So that takes a couple of minutes. So I can't really do this right now, but I can go to the one that I deployed the other day. And this problem that I keep running into, when my workspace gets, I'm sorry, I'm losing my workspace every now and then. Let me see if I can bring it back. One minute. Okay, I think I might have to owe you that one. Okay, so, okay, there it is. Maybe we can go back to this. Find the... Okay, so I want to get my workspace. Okay, and that workspace returns me a score, like the service has a scoring URL, and then I can actually go and run against that service. So the same model that I did earlier, I'm actually scoring that one. So it's a different number now, but it's equally correct. Okay, so that's all I had. This is the Python SDK for Azure ML, and it will be available later this year as part of the Azure ML offering. If you're interested in privately previewing it, please come over to our booth and have your badge scanned so that we can inform you when we're ready for you. Okay, thank you very much.